Okay. To implement Wein Bridge Oscillator using op-amp and observe output waveforms on CRO. The apparatus required for the experiment are breadboard, IC741, resistors of 3 resistors of 1 kilo ohm, capacitors of 2 capacitors of 1 microfarad, and 1 RPS, CRO, connecting wires and potentiometer of range 0 to 100 K. Here you can see the circuit diagram. We are using the IC741. The inverting terminal is connected with RA, RA resistor, and RA resistor other terminal is grounded. The resistor value of the RA is 1 kilo ohms, and here you can see the feedback resistance, negative feedback from output to input. Here we are using potentiometer of 0 to 100 K. We can vary the value of the RF. Now this is the Wein Bridge circuit. Later we have to satisfy the Barkhausen criteria. What is Barkhausen criteria? Barkhausen criteria is we should get unity gain. Gain equals to 1, and it must consist of positive feedback. And that criteria is the phase shift must be 360 degrees. In order to satisfy this, we are using positive feedback. Here you can see that positive feedback from output to non-inverting terminal through resistor and capacitor, and another resistor and capacitor is grounded. Now I am making the connections. Input resistor from ground to second terminal of IC. Now feedback resistance. For feedback resistance, I'm using potentiometer. Feedback resistance is connected between output to inverting terminal, and output is 6 terminal. Here you can see that 6 pin to 2 pin. We have completed negative feedback circuit. Oh no, now we have to complete the positive feedback. For positive feedback, we have to take one resistor and capacitor and connect them in series with from output to input of non-inverting terminal. Here is 1 kilo ohm resistor, 6 pin to here, and this is 1 microfarad capacitor. Capacitor other terminal to non-inverting terminal of IC. Now here we have completed this circuit. Now we have to complete this circuit. Here we have to connect the resistor and capacitor parallel with ground and non-inverting terminal. Here this is a resistor of 1 kilo ohm. And this is 1 microfarad capacitor. The terminal to ground terminal. Now we are going to turn on the IC. We have made all the connections. RA, feedback resistance, the negative feedback completed, and positive feedback also completed. Now we are going to turn on the IC. In order to turn on the IC, we have to use dual power supply. Plus 12 volts for pin number 7. Here we have completed the plus 12 volts for pin number 7, and minus 12 volts for pin number 4. And negative terminal of first power supply and positive terminal of second power supply are grounded. Here we have to turn on the RPS. In order to In order to overcome overload effect, we have to increase the current limit. And here we had selected the channel 1 voltage. Here you can see that we are making 12 volts. You can see this. This is nearly 12 volts. And now we are going to vary the channel 2. Channel 2 current limited is increased. And voltage is, here you can see 11.9, nearly 12 volts. Okay. Now we have turned on the IC using RPS. Now we have to check the output using CRO. Switch on the CRO. Now I'm using channel 1. Make the ground connection. Then this pin number 6. Here we have to check the output. We have some voltage. By adjusting the potentiometer, we can get the output. Yes, we can see we get frequency of 162 kilohertz. See this? These are the readings. Time period. Frequency is equal to 160 kilohertz. Finally, we have made the oscillation. We have created oscillations without using any input supply. Now we have to see the output. See, oscillations are created without using any input signal. R1 ratio, value of R1 is, this is R1, C1, R2, C2. Value of R1 ratio is 1 kilo ohm, R2 ratio is 1 kilo ohm, capacitor C1 value is 1 microfarad, C2 1 microfarad. We get practical frequency of 162 Hz, 162.9 Hz. We're going to find out the theoretical frequency using formula. Here, for the Wein Bridge Oscillator, in order to find frequency, formula is 1 by 2 pi RC. Here, 1 by 2 pi, R value is 1 kilo ohm, 1 into 10 to the power 3, and C value is 1 microfarad, 1 into 10 to the power minus 6. Here, by calculating this, we get 159.15 Hz. Here you can see that we get theoretical value and practical value very near.